Innovative models for Vitreoretinal training during COVID times.
COVID times have really been stressful for all healthcare workers and medical fraternity. Of all the affected domains, learning and residency seem to have taken a back foot. In this regard, vitreoretinal training, that is lasers and surgery, have been affected mostly. Simulator-based learning is very important for skill transfer both for surgery and lasers. The basic orientation for a fellow to begin laser is the inverted and laterally reversed image seen through the contact lens and focusing the aiming beam on the retina. There are very few eye models for practicing retinal lasers. Commercial eye models do not cater to disease-specific learning and are expensive too. We describe a simple, customized and cost-effective eye model for retinal lasers and VR surgery. We describe the Retilap eye model. The eyeball framework is done by cutting a ping pong ball in half. An aperture of 5 to 6 mm is made in one of the hemispheres which simulates pupil. An A4-sized drawing paper is chosen and a retinal diagram with the desired lesion is created on Microsoft Paint or similar program. The image is stored in a portable graphics format and 9 copies of the retinal diagram can be printed per A4 size paper. The retinal diagram is cut in the form of a circle. 4 slit-like apertures or wedges are made in the corners and assembled inside the ping pong ball. And regular contact lens for laser photocoagulation is used to practice lasers. The used retinal film can be replaced by a new one in the same framework. A discarded electrical junction box with a hole in the lid and the plastic tube at the other end attached is used. It is very cost effective and the burns produced resemble those on human retina and power settings are comparable to real life scenario. Focal, grid, barrage lasers can also be practiced on the same. Wet lab eye models have been the traditional approach but has its own limitations like availability of eyeballs and the instruments cannot be used on human eyes again. Simulators are very expensive and not available in all centers. We have designed a simple, cost-effective and practical eye model, Retisurge. The model eye is designed by 3D printing. An eyeball is sketched for its anatomy and incorporated into a software with appropriate dimensions. The model eye is consisting of 2 hemispheres. The upper one is made of TPU, thermoplastic polyurethane, which has the same elasticity as sclera and is flexible, and lower one is made of PLA, polylactic acid. A color-printed sheet is folded into hemispheres based on the concept of K-comb wrapping and traced and customized using a 3D printer. The same is used on the printout so that it fits perfectly onto the eye model. For a realistic image, polyethylene terephthalate glycol sheet (PETG) sheet can be used instead. A microscope handle cover is fitted into a cardboard box with a hole at the center and the eye model is placed over it. 2 ports that simulate sclerotomies can be made in the superior part using a trocar that allow introduction of instruments into the posterior segment. This assembly is then used in conjunction with the operating microscope fitted with a biome to allow stereoscopic view and practice various steps of VR surgery. It is cost-effective and can be practiced inside the operating with available instruments. The practice of non-dominant hand maneuvers and flexibility can also be done using the eye model. The basic concept of core vitrectomy is vitreous removal without losing focus of microscope. Endo laser can be practiced on the PETG film which produce burns comparable to human retina. It also creates a sense of awareness of instruments inside the eye to avoid touch. It also decreases anxiety and complications and improve performance. In conclusion, these two innovations are simple, cost-effective, reproducible, and have helped a long way in VR training during COVID times. Thank you.